Hello, this is Mr. Wakefield, and we're looking at the last section right now in Chapter 5. That's Section 5.7. You probably hope you remember, since it was so shortly before now, that in Section 5.2 we talked about matrices, all right, and we use those matrices for those big system problems. And the one thing about matrices that was real good is that as I look back into Section 5.2 real briefly here, is that matrices allowed you to write the problem without the variables. Okay, and as long as we had the columns organized and stuff, we knew where the variables were without having to write them. And so matrices have a nice purpose in that regard. They make things easier for us by not having to write the variables. So it would make logical sense as we go forward here now in 5.7 that we would want to know how to do some operations with matrices, how to work with them, how to combine them together in some cases. Not that you would ever do these things in 5.2. It's not necessary to do them in 5.2. But in the future, if you ever need to add or subtract matrices or multiply matrices together, okay, that kind of thing, we're going to talk about that. So, first of all, how do you add matrices? And the subtraction is very similar as well. As he says it's the same for when you subtract. In order to add two matrices, okay, the key thing is that it must be the same size, the two matrices, all right? What does that mean to be the same size exactly? It means that it has the same number of rows and columns, okay? In other words, it looks exactly the same, all right? If you have the same number of rows, by the way, rows are the things that go across. So this one right here has 2 rows, and it has 3 columns. The columns are the things that go up and down. So rows are horizontal, columns are vertical. That's going to be really important here for you to understand what we do next here. Now, could I add these two matrices together? I could not, because they're not the same size. All right. This one has 2 rows and 3 columns. This one has 3 rows going horizontal and 4 columns. So it's a completely different size. All right. They need to be the same size. Now, that doesn't mean that we can't multiply them, but I'll get to that a little bit later in this discussion. But right now, adding and subtracting matrices, you can only do it if they're the same size. So you can see right here, these two matrices are the same size. We have a subtraction symbol in between them, which obviously indicates that they want to subtract the matrices. Since they are the same size, meaning they have the same number of rows and columns, you can see here that they both have 2 rows and 2 columns. And so we can add them. I'm sorry, subtract them. This is a subtraction problem. So what you do is very simple. All you got to do is just subtract the common numbers here in the common places. In other words, the top left-hand corner minus the top left-hand corner. The bottom left-hand corner minus the bottom left-hand corner. Just subtract the numbers that are in the same position. Okay, and then the answers will then go in the same position as well. So if you go top left minus top left, that answer goes in the top left. That makes sense, right? Okay, so top left minus top left, 11 minus 0 is 11. All right, it goes in that same place. Bottom left, negative 4 minus 0, that's negative 4. And again, that would go in the bottom left as well. Top right is 0 minus 12. That answer, negative 12, would then also go in the top right. And finally, 0 minus negative 14. All right, remember that's a double negative. Subtract a negative. So that's going to be 0 plus 14, which is 14. And so we have our answer right there. That's all you got to do is just subtract the numbers that are in the same spots and then put the answer in the same spot as well. If there was an addition symbol in between, you'd do the same thing except for you would add instead of subtract the numbers. Okay, that's the only difference. Problem number 2 here. It says to add these two matrices together, but am I allowed to do that? No, I'm not, because even though they both have 1 column, they have a different number of rows. This has 3 rows here, but this one only has 2 rows. So the two matrices are not the same size, okay? So we can just simply say cannot be added together, okay? And the reason why is because they're not the same size. All right, not same size. Okay, now, so that's adding and subtracting matrices. We're going to talk about that a little bit more here as a part of the next two problems. Notice in the next problem here it says A is a matrix, right? But then it says multiply that matrix by just a single number. It is okay to do that. You can't add or subtract a single number like -2 to a matrix, but you can multiply it. It's called scalar multiplication. All right, with the multiplication, you're allowed to do a single number times a matrix. Okay, so this is only for multiplication here. So if you're multiplying a matrix by a single real number, this is called a scalar. Okay, when they multiply just a single number times a matrix. And what you do is you just simply multiply that number that's separate from the matrix being multiplied by it. You multiply that by each of the numbers inside the matrix, and then the answer just goes in the same place that the original matrix number came from. Let me show you what I mean. Okay, so let's do -2a. We'll deal with the 4b after that, okay? But what is -2a? Let's do that off to the side here so I have enough room. -2, and then the a is this matrix right here, -2, 4, 0, and 3. So all you got to do is multiply the -2 by each one of these things, and then the answer just goes in the same place. So -2 times the top left, that is equal to 4, and so it also goes in the top left. -2 times 0 is 0. Since 0 is in the bottom left, we put the answer in the bottom left, and so on. -2 times the top right is equal to -8, and so that answer also goes in the top right. And then finally, -2 times 3 is -6. Also put that in the same position. Okay. Now, we also need to do 4b, okay? Again, you can see that we have a single number times a matrix. Let me just do that over here off to the side so I have enough room to put the answer here. There we go. So what is this going to be equal to? Again, when you have a single number being multiplied by a matrix, you just multiply the 4 by each one of these 4 numbers and then put the answers in the same locations. So we get -24, 16, 8, and 0. Okay, just multiplied by 4. That's all I did. Okay, now you add. Why would I wait till now to add? Okay, as the addition symbol tells me to do. It's because, as you guys know, okay, in order of operations, multiplication comes before addition. And so it makes sense that with matrices, that similar kind of thing would happen. All right, that we would multiply the scalars before we add the results. Okay. And so, again, can I add these? Remember, we got to ask ourselves that question. All right, whenever you add two matrices, are they the same size? Yes, they are. Okay, you can see that they're both 2 rows and 2 columns. All right, so that means I can add top left and top left. Answer goes in top left. Bottom left and bottom left, 0 plus 16, that goes in bottom left. -8 plus 8 is 0. That goes in the same spot as those 2 numbers were in. And then finally in the bottom right, -6 plus 0 is -6. Okay, and that is going to be in the same position as well. Okay, so that is your answer right there. We multiplied and then added as the problem implied. Okay, just like if the A and B were just normal numbers, the way you figure this out is to multiply the 2 things and then add, right? Okay, well, this is no different. All right. This one here is, again, is similar. There's nothing being multiplied by the B. We're just subtracting it, but we do have A times 3/4. Let's pull that off to the side. They're going to be a little bit tougher on us this time because of the fraction. I'm going to have to deal with some fractions here a little bit. Okay, what is this equal to? Again, when you have a single number times a matrix, you multiply the 3/4 by every number on the inside. And so 3/4 times -2 is going to be You can cancel first, or since these are simple fractions, it's not a big deal if you just multiply first and then reduce. All right. Normally you wouldn't do that on the bigger fractions, but here you can. That ends up being -3/2, doesn't it? If I then put that answer in lowest terms like I normally would. Okay. 3/4 times 0 is 0. 3/4 times 4. Okay. Since the 4's are the same, and since I'm allowed to cancel those in this case, because those are both just single terms, I get 3/1, which is 3. And so that 3 would then go where the 4 was, since I multiplied by the 4. And then 3/4 times 3. 3/4 times 3 is what? That is 9/4, isn't it? Nothing cancels there. And so we just get 9/4. 9/4, sorry about that, there it is. 9/4 is already in lowest term, so we can just bring that down. Okay, so now what do I got? Now I have this matrix that I just made. Let me just bring it down. And it says to subtract b. Again, is b the same size? Because otherwise you can't add or subtract either one of them, right? You can't do either addition or subtraction unless they're the same size. This is subtraction now. Remember, you got to multiply by the scalar 3/4 before you add or subtract. In this case, subtract. So I did the scalar first. That's what we just produced here. And now that I subtract, since they are the same size matrix, I can actually subtract. 3/2 minus -6. Remember, that's the same thing as +6 because that's a double negative. All right. What is 3/2 plus 6? Well, 3/2 plus 6 is 6/1. That would be 12/2, wouldn't it? I apologize. I meant -3/2. -3/2, as you can see over here in the problem. So that would be -3/2 plus 12/2, getting a common denominator right there. Okay, and that gives me 9/2, doesn't it? And that fraction's in lowest terms, so that's your first number in your final answer there. 0 minus 4, you guys. 0 minus 4 would be -4. I'm just subtracting the corresponding elements here. They're in the same positions. 3 minus 2 is 1. And finally, 9/4 minus 0. Anything minus 0 is itself, and so it just stays as 9/4 right there. And that is your final answer. We multiplied and then subtracted. Okay. So that is how you add and subtract matrices, but it is also, we also talked about how to multiply a matrix times just a single number as opposed to another matrix. However, as we move forward now, how do we multiply a matrix times another matrix? Not to be confused with when you have a matrix times just a single number. Okay, well, this is much more involved. Listen closely here on this. Okay, there's a few things I need to tell you first since it's a much more involved problem. Okay, let's talk about that. Matrix multiplication. In order to multiply one matrix times another matrix, again, not to be confused when you multiply by just a number, we must first realize that in general, if you do A times B, it's not going to be the same thing as B times A. What that means is, unlike regular multiplication where, for example, you know in regular multiplication that 7 times 3 is the same thing as 3 times 7, right? Okay, you can reverse the two numbers being multiplied and it's still going to give you the same answer. That's not true when you multiply a matrix times another matrix, okay? So don't just think that, oh, hey, I can reverse it because I just want to for whatever reason, okay? No, you can't do that, all right? If they tell you, for example, in this current problem here, if they say to do this one times this one in this order where this one's first and this one's second, then you must do it in that order. You can't then take the second matrix and then put it in front, okay? Matrix multiplication does not work that way when you have a matrix times another matrix. Okay, so just wanted to clear that up just so you don't just so you don't make that mistake. The other important thing to realize with matrix multiplication is that the number of columns in the first matrix must equal the number of rows in the second matrix. Otherwise, you can't multiply. You'll understand better why the multiplication wouldn't work when I actually show you a problem here, but that is true there. Let's make this a little bit easier to understand. Okay. Notice it says right here, suppose you're multiplying a 2 by 3 matrix by a 3 by 4 matrix. What in the world does that mean? What this means is this. We always, whenever we say 2 by 3 or 3 by 4, that means that it's 2 rows and 3 columns, 3 rows and 4 columns. In other words, when they say 2 by 3 or 3 by 4, the first number is always the number of rows. And the second number is always the number of columns. So 2 by 3 means 2 row, 3 column. 3 by 4 means 3 row, 4 column. Okay? Now, as it says up here, okay, it says that the number of columns in the first matrix must equal the number of rows in the second one. All right? So that, in other words, this number right here must equal this number right here. Columns in the first must equal the rows in the second. Is that true here? Yes, it is. They're both equal to 3. That means we can do it. But there's even more to the story than that, okay, in order to get this answer correct. If you're allowed to multiply these matrices together, because these two middle numbers, not to be confused with 2 and 4 on the outside here, but if these two middle numbers are equal, then the two outside numbers are going to tell you what the size of your answer is, and that's really important. Otherwise, you'll be completely confused on how to start the problem and how to proceed with the problem and all that. So, what you do is you take the two outside numbers, and if you combine them together, what does it say? It says that our final answer is going to be 2 rows and 4 columns, otherwise known as a 2 by 4 matrix. Okay? 2 by 4 matrix is going to be what your answer looks like. All right? And that's exactly what I have down here in this example problem right here. All right? Again, this is a 2 by 3, just like I mentioned up here. This is a 3 by 4, and since they want to multiply it in that order, okay, you can see here they want to do A times B, not B times A. They're doing it in that order, okay? Since the A column and the B row are the same number right there, then these two numbers are going to tell you what the answer looks like. So notice that the answer, and I'll show you how I got the answer in a minute, but I just want to show you what the answer basically looks like, what the size of it is. I want to show you that first. But notice that the answer is 2 rows and what? It has 4 columns. That's exactly what this thing here told me it would look like. And so when you set up your answer, you guys, you want to know what the size of the matrix is so you know how many numbers you need. I'll tell you how to find those numbers here in just a second, but you need to know how many numbers you need and where to put them. Otherwise, you don't know how to get started, right? Okay, so we know now that when we have these two middle numbers being the same, the two outside numbers tell you the size of the matrix. And so we know that it's going to look like this. Now let's talk about how we got these numbers. Okay, and we'll practice more of these on the back side of the worksheet. This is just a sample problem that's already been done. Okay, notice that this right here, I'm going to give it a name here. You don't have to use these names if you understand it in your mind already, but I'm going to call this, I'll just call it, well, even though it's A times B, I'm just going to give it a name here. I'm going to call it, let's see, what was the name that I usually use here? Oh, yeah, we can still call it A. I thought maybe I had a more creative name there, but it's okay. So the A is just saying that this is one of the numbers on the matrix. But look at the little 1, 1 right here. Again, you don't have to do this part here where you write out the A 1, 1, but just trying to make it easier for you to understand where the answers come from. Okay. Since this number is in the first row in the first column, I call that 1, 1. Since this number right here is in the second row in the first column, I call that 2, 1. Remember, the row number comes first. Whether you write it with that X thing in between it or not, okay, the row number comes first. All right. This one right here is what? This one is second column, first row, and so that would be A1, 2. Okay, first row, second column, 1, 2. All right, and then so on. So this one's going to be second row, second column. This one right here is first row, third column, first row, third column. This one right here is second row, third column. And then finally we have what? We have first row, fourth column, and second row, fourth column. Again, the reason why I give these things these little A names right here is just it helps you see where the answers are coming from. So see how in order to find the 23, what you do is you have to look at the first row of the first matrix and the first row of the first column of the second matrix. Because remember, the first number is row, the second number is column. But in particular, even further than that, is the fact that the first number goes with the first matrix and the second one goes with the second matrix. So first row, first matrix, first column, second matrix. Don't worry, we'll do this a lot here. All right, I know you're still probably just getting used to it. I understand that. Okay, so let's see how do we figure out A11? It's saying to take the first row here, first row, first matrix, and first column of second matrix. And what they're asking you to do is to take the first number and the first number, multiply it. You see 3 times 3 right there. And then you take second number, you multiply that, 6 times 1. And then third number, 2 times 4. You figure out what those are equal to because you have to multiply before you add. And then you're supposed to add those results together. So we get 9 plus 6 plus 8 on the multiplication. And then if you add those 3 numbers together, you get 23. And that's where this 23 came from. Let's try that again now. Okay, suppose I wanted to figure out this number. Let's say we didn't know that it was equal to 32 yet. Okay, the way you do it is you got to realize that the 2, 1 means that, again, it's second row, first column. Okay, that's why we call it that. But it also means that when you go up here, because it says 2, 1, that means you take the what? You take the second row from the first matrix. Okay, the first number's got to be row and the second one's got to be column. So you take the second row from the first matrix and the first column from the second matrix. 2, 1. And you do exactly the same thing that I just did in the 23 number. You multiply first and first, 1 times 3. Second and second, 9 times 1. And finally, third times third, and we end up getting 32 when we multiply and add. Okay, so we do that exact same thing. Let me just do one more here. How did I get 86? Excuse me. How did I get 86? Again, that is in the first row and the second column. That means that I need to take the first row. Let me erase this. And this. 1, 2 means we take the first row from the first matrix and the second column from the second matrix. Okay, and we do the same thing. 3 times 6 is what? Let's write that down. 3 times 6 is 18. I'll get to that in a minute. 6 times 9 is the next one. And finally, 2 times 7. And then after we multiply those 3 things together, we have to add them together, add the results together. I get 18, 54, and 14. So the final answer there is going to be 72 plus 14. And sure enough, as expected, that is equal to 86. All right, so that's how it works. Let's go ahead and actually practice it on some problems that haven't been done already, and let's see how we do. Okay, now, just like so in number 5 here, the way to figure out if you can multiply it or not is write out the size of each matrix, like I did earlier when I did this thing where it was 2 by 3 and 3 by 4. Okay, let's do that. So this one, again, is also going to be a 2 by 3 because it's got 2 rows and 3 columns. Remember, the row number always goes first. And then this one is 3 rows. This little skinny one is 3 rows and 1 column. Okay, so the question is that, are the 2 middle numbers the same? Yes, they are. Since they are the same, you are allowed to what? You are allowed to multiply these together, but only if those are the same, the 2 middle numbers. If they are the same, though, then your answer will then be determined by the 2 outside numbers. Okay, since the 2 outside numbers in order, again, order is so important in these problems. In order, it is 2 by 1. Okay, so the answer is going to be a 2 by 1 matrix. That means what? 2 rows, 1 column. 2 rows, 1 column. All right? So my answer is going to look like 2 rows and 1 column. That means it's just going to be 2 numbers. Okay? It's going to be 2 rows and 1 column. In fact, I will give them names here. Again, you don't have to do this. This part is optional, like I said. All right? This one is first row, first column. First row, first column. And then the second one down here is first row. I'm sorry, I said that backwards. Excuse me. That one is second row, first column. Okay. And so we now know, because of these names right here, A11 and A21, this tells me to take the first row from the first matrix and the first column from the second matrix and multiply those together. So first row from first matrix, first and only column, there's only one column there, but first column from the second matrix, and multiply those together. What do we get? -6 times -2. That's the first one there. Okay, I just put brackets around them because they're negative. And 3 times 0, and then 5 times 3. Okay, first times first, second times second, third times third. What do we get here? We get 12, 0, and 15. What does all that add up to? That's going to add up to 27. What is the second number going to be? It is what? It is the second row from the first matrix and the first column from the second matrix. So let me just erase off the old one here. You get this right here. So we get what here? We get 2 times -2. All right. 9 times 0. And 1 times 3. Okay. And what is this going to be equal to here? It's going to be -4 plus 0 plus 3. And that is equal to -1. So our final matrix here is those two numbers right there in those two positions. Okay. Sorry, that came off the screen there. Excuse me. So -4 plus 0 plus 3. Okay, that's what gave me the -1 up there. Okay. So that's the first one. Let's try 3 more here. Number 6. Again, we don't multiply matrices together unless we first of all determine, just like with addition and subtraction, can we add them? I'm sorry, can we multiply them together? This one right here is a 1 by 3 because it is a 1 row and 3 column matrix. 1 by 3. This one right here is a 3 by 3. 3 rows and 3 columns. Again, can I multiply? Well, if the two middle numbers are the same, you can, and they are. So because they're the same, we then take the two outside numbers, and that determines the size of your answer. Okay, so since, and again, order is so important here. You got to do the 1 first and then the 3. So it's a 1 by 3, not a 3 by 1. A 3 by 1 is a completely different matrix. So 1 by 3 is your answer. Okay. So that means that we're going to have 1 row and 3 columns. And so it's going to be just like this one. Okay, 1 row, 3 columns. So you're going to have A11, meaning that this is the first row and the first column. This one right here is the first row because there's only 1 row. First row, second column. Okay, because this is the first column over here. Second column. And then this one is what? This one is the first row and the third column. Let me make that easier to read there. First row and third column. So what are these 3 numbers going to end up being equal to? Okay, what does 1, 1 mean? It means first row multiplied by first column. First row multiplied by first row from the first matrix, first column from the second. So we get, I'll go a little bit faster now than the last problem. Okay, 0 times negative 2 is 0, plus 3 times 0, which is also 0. So far we have 0 plus 0. And then negative 4 times 1 is 4. So our answer then for that first one is going to be 0, 0, plus 0, plus 4. And as you know, that's equal to 4. Okay? What would the next one be then? Again, it says first row, second column. So that means we're going to do first row in the first matrix, second column in the second matrix. So let's do it carefully here. 0 times 6 is 0. 3 times 4 is 12. So we have 0 plus 12 so far, which is 12. And then plus negative 4. So 12 plus negative 4 is 8. One more to go. First row, third column. Okay, that means first row in the first matrix, third column in the second one. There we go. All right, so 0 times 3 is 0. 3 times 2 is 6. So 0 plus 6 so far. And of course, that's equal to 6. And then plus negative 16. Plus negative 16. So what is 6 plus negative 16? Negative 10. And there's your answer. Okay. Okay, a couple more to go here. This next one is the big one. All right, this one has got a lot in it. We'll go through it carefully here. All right, it's basically the same stuff. It's just a longer problem. Both of these matrices are 3 by 3s, aren't they? They both have 3 rows and 3 columns. Okay. Now, they didn't ask us to add or subtract these matrices. They asked us to multiply them. But if they were to put a plus or minus in between the matrices, we could add them or subtract them as well, couldn't we? Because they are exactly the same. But when you're multiplying, the only thing you're concerned about when you multiply is what? That these two middle numbers are the same. That's the most important thing. They are. Okay. And because they're the same, we then look at the outside numbers, and that tells us the size. Since the first number is 3, and the number on the far left is 3, and the number on the far right is also 3, we're going to end up with a 3 by 3 matrix as our answer. Okay. In the interest of space here, I'm not going to write down the A's over here. I'm just going to put down the answers. But we know now what those A's mean. Okay, this one right here, because it's first row, first column, we know that that one right there is A11. Okay. And so A11 means to do what? First row, first column. That means you take the first row here and the first column here. First row here, first column here. All right, I'll just circle that just so that we can visualize it. Negative 1 times 2 is negative 2. You don't have to write this out. Like I said, we can go a little bit faster, but just to do it a couple times here, just to continue to get used to it here. 2 times 0. And then 0 times 3. What is all this equal to? This is negative 2 plus 0 plus 0, which is negative 2. So that first number right there is going to be negative 2. This next element right here, this next number underneath that, and you could do this one over here next if you want. It doesn't matter, just as long as you do all 9 numbers that you're supposed to do here for this 3 by 3 matrix. But this one is what? What does this come from? This is the second row and the first column. Second row, first column. And so what do? That means we take the second row from the first matrix and the first column from the second one. I'm going to go a little bit faster now. Okay, I'll just write down the multiplications. So 0 times 2 is 0. 3 times 0 is 0. And 2 times 3 is 6. If I add those things up, I get 6. Okay? So 6 goes right there. Let me make that a little bit bigger there. There we go. And so now, what's the one underneath that? That is third row, first column. Third row, first column. So we call it 3, 1, okay, when we give it its name. All right. So third row, first column, 0 times 2 is 0, 1 times 0 is 0, and 4 times 3 is 12. Final answer there is 12. Okay. The next number over here in the next column, that is what? That is the first row and the second column. First row, second column, we call it 1, 2. Not to be confused with 2, 1. Okay, again, the order is so important here. So that means what? Okay, I'm not going to keep on circling these. Okay, I think you understand now where I'm getting these from. 1, 2 means first row, second column. So let's just do that carefully. First row and second column, -1 times -1 is 1. 2 times 2 is 4. And finally, 0 times 0 is 0. Again, I got that from the first row in the first matrix, second column in the second one. 1, 2. First row, second column. I get 5, don't I? Okay. The one in the middle here is what? That's the second row in the second column. We call that A22. All right. And again, what do we use? We use the second row in the first matrix, second column in the second matrix. All right. The first number goes with the first matrix. The second number here goes with the second one. And the first number is always the row, and the second number is always the column. So what do we got here? We got 0 times -1 is 0. 3 times 2 is 6. 2 times 0 is 0. Final answer there is 6. Okay, we're about halfway there. The one underneath that is the third row in the second column. Okay, the next one underneath the second 6 right there. And so that means that we need to do the third row in the second column. Let's do that. Third row and second column is going to be 0 times -1 equal to 0. 1 times 2 is equal to 2. And finally, 4 times 0 is 0. I wrote that in the wrong place. I'm getting too far ahead of myself there. Sorry. And so we end up getting 0 plus 2 plus 0 is 2. Okay. 3 more numbers to go here. The next number up here in the top right is going to be the third row, the first row. First row and the third column. First row, third column. And so we got this row right here and this column right here. -1 times 2 is -2. 2 times 1 is 2. And 0 times -1 is 0. Adding those 3 numbers together, we get 0. 2 more to go here. The one underneath the number underneath the 0 is the second row and the third column. And so we get what there? Focusing on the second row of the first matrix and the third column of the second one, we get 0 times 0 times 2 is 0. 3 times 1 is 3. And 2 times -1 is -2. And what does that equal to there? 1. So you put a 1 underneath the 0. 1 more to go here. I know this is a long one. All right. And finally, 3, 3. Okay. Third row, third column. We got 0 times 2. 0 times 2 is 0. 1 times 1 is 1. And 4 times -1 is -4. If I add those answers together, I get negative 3. Okay? And so there you go. So there's your final answer there. Okay? Last one here. Again, we're multiplying a matrix times another matrix, so we got to figure out what the size is first to see if it can be done. This one is a 2 by 4 because it's got 2 rows going horizontal and it's got 4 rows going, or pardon me, 4 columns going vertical. This one, on the other hand, though, is a what? It is a 2 row, 3 column matrix, so we call that 2 by 3. What's the problem here, you guys? The problem is that the two middle numbers, again, make sure to put these things in order. Make sure the 2 by 4 is over here and the 2 by 3 is over here because the matrices are in that order. But as long as you do that, the two middle numbers tell you whether or not you can multiply. Since they are not the same, what does that mean? That means you stop right there and you don't have to do anything else because we cannot multiply it. Since those are not the same, okay, they what? They cannot be multiplied. Okay? And so that's all you got to do there. Okay? So that's why you always check first to see if those two middle numbers are the same, because if they're not, you can just stop. Okay? And you should stop because you can't multiply them. All right? So that concludes section 5.7 and chapter 5 in general. As usual, let me know if you have any questions. You enjoy your day, and we'll see you back. Again, we're going to be skipping chapter 6, so I'll see you back again for section 7.1.